Welcome again to Wickerson Studios. I'm looking back at a tutorial I gave that was inspired by Daniel Kristev's Weave GH file, which is on his own site. And it's done completely, as you can see here. And I'm not going to play the video because recording a video while playing a video of myself seems fairly odd. But this pattern, you can start to make out the node network of how it's scripted. And what I want you to see here is the similarities between what's patterned here or clustered here. Actually, it's not clustered yet, but they're grouped here. And then writing of this script in Python that does this here, which would be this here, pretty much this here, which would be this here, and then going into the B section and repeating it again with one section and two sections. So you start to see the visual node network producing a system like this and a body like this, and this is going to produce a script on the surface that's very similar. So we'll go through the details of this script, and I'll make this script available and this available to my all-access subscribers. And I hope you find it interesting. This will be the second longer video as I develop this series. And following this weaving curves on surface, we are then going to go into the chapter of shell and meshes, and things are going to get really complex. So at this point, you know, you can certainly work with these videos and pull the script out by hitting stop and things like that. But as we get more and more complex, you're probably going to want to get the access to the GH files and the 3DM files if I take some to print and to render. And we are going to try and roll it into, in an interesting way, into Revit 2021 because Rhino.Inside allows for that. So I'm going to shut this down for now, or just pull it off from my other screen. And what we have here is the Python script in front of the Revit window. So Revit 2021 is underneath this, and you can click on that and see that. But because we're working within Grasshopper and Rhino, we're going to be dependent on a couple of things. So what I'm going to do is just jump in here, shift up my view, and the first thing we have to create for this script, even though it's been written here, it's going to need a surface. And you'll have this GH script, and I've turned off my piping, my variable pipe in the end, because that's going to slow it down. We're actually just going to look at the curves for now. So basically, a surface that generates two curves, and I've thrown in a couple of interesting numpy and numq, and you'll see what those do to the script. So we'll get this basic one written, and we'll show you how it's done. The first thing you want to do as you go into these areas, and it's pretty similar to everything I do, we want to go in there and create ourselves a wonderful plane. Probably take it so you can deal with it as a shaded area. Rebuild it. You're going to find I do this quite often. My geometries in Rhino are pretty simple. I've got it set to 5 and 4, and then at that point I'll pop on my points right here, and I'll grab a little bit of points here and pull that up. Take this one and undulate that one up a little bit just for flexibility. You can always have a little bit of fun with this, and it'll slow your script down a bit, but you can always grab that and start doing things like a little twist to it, which can actually make for some interesting bends. And then the whole thing you might want to just, you know, pivot around or take the whole thing and give it a little bit of an angle in the y direction, z direction. See what happens with that. Now that's totally parametric. When we change that, we'll be taking that to visibility and putting it off. But before we put it off, we definitely want to go down here and set one surface. You do not want to reparameterize these surfaces in this script. So although I do that in other ones by right-clicking here and hitting reparameterize, we're not going to want to do that in the script. So just leave that off. Once it's set, put it away. So you're only dealing with the Grasshopper script. And what I initially have is the script that I took from the text, and I'll send you that. And this Python script, if I close this one, is right out of the book. And I don't really want to just plagiarize and give that to you. I think you've got to pick up the book and use that. But once you have a base script that, you know, you could find this on GitHub in many different forms. So this is coming from a single text that I'm pulling an awful lot of beautiful algorithms and computational designs. That's there, and it has a variable pipe, and you can put it on there and see what it does. But, you know, we're not going to focus on that one because it's not important that, you know, I generated that. And I think I've got a little node here just to prove I was getting into plugins for some reason. Let me just grab that little node there and take that to, I thought I could, I have to be in here if I ungroup. Let's just take that node off because that's not where I'm actually playing. And I'll bring that node down to Wickerson development here and say, okay, let's group that one more time. This is the base script grouped. We'll leave it purple. And then the script we're dealing with is this one. So I'll hit OK, and we'll go back into here. Make sure that you've opened the right script because you're going to play with it. And at this point, I'm just going to save my document as probably 17B So you'll see that on the GitHub file when I put it there, and there it is running as curves. Very nice. And so it's taken that surface and it's run it. It's not only run it there, it has made an effort to take that into Revit. So let me grab this and pull that up a bit. Over here, I'll just bring that up like that. And with any luck, if I run it, test, okay, in my Revit, well, obviously it's not seen under that view. I'll have to go into view. I must be in a command if that's happening. Sometimes I think I'm bugging out when I'm not. So let's just take off the Rhino command. And let's take our view in Revit over to 3D. And then you should be able to see what we have going on when I select my, my curves. So let that one load up for a second. Instead of take that off. There it is. And that should be loading up in Revit at the same time. The reason it's not is I'm curious. Let's take it one more time and run it. Okay. Test it. And we'll shrink that script and we'll go in detail. But I am wondering why my Revit is not. I've opened this within it. So it's just having a little problem here for a second. Let me just take this and bring this to a... one moment. This is just showing a little bit of problem solving and what happens. We'll take it to enable. The pipes should allow it to do some interesting things. You'll see that it's thinking a little longer now at 2.1 seconds, and it should provide a little bit more funk when it comes to that. And there we go. The piping is now allowing it to be generated in Revit. So a nice little exercise. You get these pretty cool forms. They're not baked yet into Rhino, but I could certainly do that. And you're really able, with a few twists and turns and playing with this with a 2-second script, to really see what's happening. And that's what was happening before, is I could take this to disable, and then I want to put these on visual by curves. So let's enable those and certainly put them to visible. And in doing so, there they are, being drawn up very quickly in Revit. So if you want to generate lines like this within an architectural framework before doing anything else, and realize that those lines are completely parametric through a simple system that I'll show you post-node. But let's get into the node. We brought in the surface. We definitely, we could take a look at it as multiple views here. I'll just extend that one down, or extend this one up. You've got this one turning and twisting, and that's the top view of it. And you can see how I've kind of moved that initial plane and played with that. But look at the effects of it. Look at how it reaches beyond that surface. So play around a little bit with that. We'll select objects to hide again. And what's happened here is the surface has been brought in. Your node has to be set up to produce a couple of curves, some in the U direction, some in the V direction, and I'm referring to those as curve A and B. And not unlike the script here that I was using to generate this on a surface, which is actually a closed woven form, and I ballooned it up and had some fun with that. You're going to have to set your inputs to U divide and V divide, and those will be set type hint to integer. If you don't know how to do that, come down here, hit type hint, and because I have split screen, I have to come over here and show you that that's popping up. Type hint integer, and trust me when I go through each one of those, these will be floats. I've got different floats. Actually, I have integers on the num-p and the num-q, but the multiplier is a float, and I've actually used the multiplier parametrically through another multiplier of amplifying the sine curve that I so chose to use. Keep in mind when we get here, you can go into your graph types and type in anything you want. So the file's here for you to play with, and you can really start stepping into your ranges and doing some wonderful things. But as we look at this, there's our curve. If I select things, you'll see the lines in this direction have been selected beautifully, as you can see here. And if you want to go and select your V lines, you can select those. So 2 different sets, you can play with those and do different things to them. So the script itself, when you set it up, we're going to go into it and take a look at what it is. So leave the Revit for a time. And what we have is a script that comes out of a text, but has been manipulated. I am not going in here and typing in import Rhino.geometry as RG, because then I would output geometries. And I'm okay with what I'm getting because I'm using Rhino script syntax and it requires identifiers all the time. All these functions, surface domain, evaluate surface, surface normal, copy objects, they all have Rhino common scripts in them that go much, much deeper. And I do have a friend that's working on that, and we will show Rhino functions as they break down and how to compile those, and you'll have a better understanding of Rhino Common, and you'll have a better understanding of how to program in C from what you're doing in Python. So it could be very good for the developers that want to go that way and work on their own plugins. As for now, you've got the first basic setup almost all the time the same. Taking a sample surface A, and sample surface A, if you go down here, you'll see you're going to be doing the exact same thing again. So if I go here and I grab my definition of sample surface A, all the way through to outputting curve A, that's going to be completely repeated here with sample surface B, turning out curve B. But there's a few subtle changes, and we're going to try and highlight those as we go through. So the script itself comes from this really good text, ghPython computer-aided geometric design, but I've tried to get in here and play with it a little bit. I will in times poke around, and hopefully this group will dig deeper into Rhino geometry namespace and trying to convert Rhino script into Rhino geometries and Rhino common, things like that. And then the other thing is I definitely could do this. It doesn't really matter because I have used my sine post. I brought in my post manipulation of these curves, brought it in as a range function, and used the graph mapper to bring in sine. But if you wanted to start tucking these things in here, you could consider what you could bring in as an import into your Python script. You also could bring in your import random things like this, and then whenever you need it, you just type in random and get the random integers and start playing with those. Floats and integers, whatever you feel works. I think the F range works much better for me in Rhino script as opposed to Rhino geometry, so I'll probably stay with that. But the base script is defining a domain U, domain V, and then using the surface domain function to set it in the U and V direction coordinated to U and to 0 and 1. And once again, whenever you do this, I'm just going to show you a little fast thing here, which I show in all videos. Go to the end of your script, hit copy, go down to the next line, hit paste. It'll copy that. We're not going to use this so much, but I'm going to bring this back, and I want to show you from the start of when you start doing this. Set up your function and hit parentheses and go down here and see exactly what's needed. And it will tell you exactly what's needed. It's going to need a surface ID, which is why I have this Rhino script syntax producing the GUIDs, and it will need a direction, and the direction being 0 for U and 1 for V. So that's done, and I'm going to keep my script small, so I'm going to delete all this. But that's what you should be doing as you're learning this. You should be breaking those down and seeing what it is. Then you're going to set up two variables, du and dv, and you're going to find the average of those, pretty simple, by minusing one direction by the other direction, and then dividing it by the count in the u direction and the v direction. If that's not geometrically making sense, then you want to dig a little bit into algebra and kind of visualize it, get a piece of paper and pen and start drawing that out. Now it's all visualizing over here for you, so it can be pretty exciting. That's what's amazing about learning script and then having Grasshopper and Rhino open or Revit open. So you're actually seeing that the visualization geometry here is secondary, even though that's what you see in the end, to what the geometry has to be understood within the logic of the script. So that's something I learned from Lon Nguyen. So try and understand that. Try and wrap your head around that. That's how I think about things. And if you're not at the stage of scripting a little bit, what's happening after here is I'm actually having fun. This is how I get the warping, and I'll show an example of this. If I make these the same, like 3 by 3 in pnum and pq, you can still see it stays a pretty nice, tight function in this direction. Like it doesn't go wandering off anywhere. It's got a little squiggle that's going up and down and jostling more here than there, but that's because we're multiplying by the iterations i's and j's. But I put in the pnum into my script because I don't want to just copy and paste. I want to be like Daniel Schiffman in the coding train, and he just keeps building upon his scripts and building and building, and you realize the infinite nature of these base scripts and what you could do geometrically, architecturally, robotic path milling into structures to carve or to mill negative spaces for casting. Fabrication techniques obviously come from this type of programming, and hopefully I'm dealing with a series of patrons that are getting much more deeper into this. I do not have an engineering or architectural background, but I do have a mathematics and programming background that went very much into visual arts and creating artwork. And I invite you to look at the last few decades of things I've generated, analog and physical, on my land. But now I'm working completely cerebrally, conceptual exercises of programming and computational studies. And I hope that's your interest as well. So you could have left this as +1 and +3 and +3. But what's the nice thing about this is watch what happens when I put that 1p, num p and num q is different. All of a sudden it jumps off and jostles in this direction. If we get this ability to really start playing with form and having fun. So once again, the logic I'm playing with number and integer is affecting the geometries, the visual geometries that are happening off to the side. And I'm very excited about where that can kind of go and wander. And it's not a wandering function, but look at how that just streams up into the distance. So you get these wonderful canopies and systems of line and to fabricate and have fun, and certainly take these to smaller prints and run them in the sand molds and cast them in bronze and polish them up in stainless or whatever you want. That said, that's a pretty good breakdown of why I brought in the NumP and the NumQ. You're obviously appending lists as you create them. So this row list was created here. The point list was created here. Any data you're given has to have the information before it. So as we're returning P, obviously P is defined by appending the empty P list with the row list, and the row list is being built by appending using the Rhino script syntax evaluate surface at that surface, which you've defined as the input surface. So a lot of times when you can't find things like surf in here, obviously look back to your inputs and make sure they're matching the proper type hints and the access of lists. Or because imagine if I start taking this to multiple surfaces, which is totally possible. I'd have to go back in here and get in probably list access and things like that. I'm just going to leave that on because I like the blue and orange because it visually makes me happy. Once that's done, you then consider, you've broken it up, what you're going to jostle and jump and lift and raise and lower. So as we go in here and look in the right view, you can see those rippling effects that one curve will ripple high at one end, but as it gets to the end, it smooths out a little bit. And that's what's really happening in here. And I do like this little technique of putting on turntable now, because then you can turn your right angle into a perspective view very quickly to that plane. So you're able to see that. Not a lot of people do that. It was something I just happened to find, and I kind of like that. I'm going to hit escape. But now, obviously, if I wanted to reset my viewport layout, I'd have to go back and set it like that, and then go back in, and then always keep your standard to zoom extends all, and you've got something to look at. Of course, my Rhino window is dropping down a little bit. Anyway, I am happier with the perspective view currently, and probably even the top view, because it really shows the what's happening within the script as it moves and wiggles. So this is where you break it down into sections. This being section, I'm going to repeat 4 times. This function is coming out of the sample surface A, and you're going to want to get in here and do a double iteration. And what modulus 2 does when you set it equal to 0 is it's saying, is it even or is it odd? And in doing so, it's skipping every other one, and it's moving the objects up by a multiplier. So in here, again, that should start to make sense that as I go in here and take a look at the right view, you'll see I can amplify and flatten those curves to smooth them right out and then start to jostle them up. So I'll zoom in here and you'll see that how that amplification has an effect. Now it also has an effect because at post node I dragged it over here to the radius of the variable pipe. And I'm not going to slow down my script with that, but you can imagine that as I change those to be higher, they end up getting thicker as well in their diameter. So that's just something I'm playing with. And you will understand that when you play around with the GH code when you download it, if you're going to go for all access on the Patreon site. So that should start to make sense as you're finding every other point along that curve, the I and J, you're going to move it up and move it down. Now you'll see this is just positive multiplier and this is negative multiplier. As we go down here to the else, then it's going to swap that up and go negative positive. And that's really the main key to that script change. So everything else pretty much remains the same. There's nothing fancy. And then you repeat the entire script. And I don't mean to have this big thing here. Repeat the whole script again and go in and do your sample surface B. And in doing so, the only changes that are happening is you will notice that for the I list range of this running through NumP and NumQ, I might have to hit pause because my kids are getting a little loud on a Sunday, and I asked them not to for 20 minutes. It's been almost 20 minutes, so I can't blame them. So I've shifted this from, you have to watch these little subtleties of for J iterations as opposed to for in A, then you're going to have to shift over in the B sample of going through the J iterations. And watch those little subtle changes as it goes. Everything else stays pretty much the same, and you're running your NumQ and NumP, which you can change and alter, and you will do the exact same thing for the length of point be throughout that, and I'll let you kind of walk through this. I'm not going to build it with you because it takes a little more time, and I think for those that want to have a consultation and actually physically build this, just watch all those subtleties of that negative popping in here and going positive, because if you don't do that, you'll end up having the same curves over top of the same curves, and you won't like what you did. But if you gain control of those little negative and positive and I and J iteration switches and swapping, you're going to end up doing some very interesting surface geometries that will build a nice meshed woven pattern that can be made solid, can put into a fabrication line. Depends what your means of CNC or whatever you're doing afterwards is. So I'll probably take mine to print and then put them in sand molds and cast them into metals. So I'm going to leave that file for those that want to go deeper into this. These are only like 20-minute breakdowns, a little more detail than my other one. The scripts are available. I've got a few patrons that I'm going to send this to. And then just in the end, as we go into here and shrink this script and take a look at the Rhino window, let's activate our variable pipe, and I'm just going to do that off the screen. Enable, and that's going to slow down a little bit and run through 3.5 seconds for the script. Take a little bit of time here. I'll sip a little bit of tea as I wait, and there we go. It's loading up in Revit. Really nice system of thinking that is the idea of what programming might and honestly is. And in the end, I will leave my script, put it back to the two that I have, give myself a plug on my own personal things, and then here in Rhino, we can go over here and have a look at that. I'll downsize my Grasshopper window, and we'll take a look at a few of these screens. We'll go over here to rendered, go over here to technical. This is what I usually prefer to see things when they're done. You don't have to do it. Find your own preferences and customize your own preferences. Zoom extends all, and there we go. We've got a pretty nice system to explore this. And when you're ready, go back into the Grasshopper, obviously, and be happy with what you have. And if you like the iteration you have, take it here, grab a little bake. Make sure you group everything. Now, if you don't want to group everything, you want to definitely do you want to separate your nodes of variable pipe and make sure if you want different materials on it, you want to put all your U direction curves together and your V direction curves together. That'll take a second to load at 3.5 seconds. I'll shut this down when that's done. You usually can wait around and see when things go, and there we go. I'm going to leave this script here. Just give it another 3 seconds to run. We don't need our Python open, but it's not letting me do anything right now because it's thinking. It's a little angry because I've got a pretty complex script going. There it is. I'm going to shut down my Python. That'll just take a second to shut. Everything takes a little bit of time. And I will leave this so I'm not seeing the orange is not selected and I'm not seeing the blue. And then we can go in here and really see what we have. Now, I'm very interested in this as an object and a watertight object. I'm interested to take it to print. It does wander off a little bit impractically in that direction. But if you're a sculptor and you see a possibility of using this in your work, if you're an architect, want to do this, never would I be generating these geometries in Rhino, and certainly I would never be generating them in Grasshopper, and of course in Revit. So this would not have been something that I would have pulled out and thought to reference and pull into elevations and surfaces and sections. And I'm not going there yet in this series. I really want to get down that we have a lot of great scripts to play with, and then we'll complicate things with Rhino.Inside and making some choices that I hope people find interesting. Rhino is here. Grasshopper's here. Back over here we have our Python. I just want to keep that script running, and I think I can get it here. There we go. And I just want to pull up my little Python script again because it's all ready to go. And it's available for you to play with. If you are cutting and pasting anybody's script for intellectual property, make sure it's pretty general and basic that you could discover it and create it on your own. Then you kind of gain access to that intellectual property. And please go through adding additional inputs, being playful, add to the site. It's about a growing community that uses and builds upon, keeps our feet on the ground with the scripts that are available to us, and then puts our head on our shoulders to figure out what we're going to do for the future. So 25 minutes. I thank you very much for watching, and I thank you very much for your patronage, and I will continue, and I will work my butt off with this. Returning to computational design has been such a highlight of my life, so thank you very much. Michael Wickerson, Wickerson Studios.